Okay, so in this next video, what we're actually going to look at is calculation of the degree of saturation. So this is a continuation from the previous video where we looked at finding the specific humidity. So degree of saturation, it's a fairly simple calculation, and there are two ways to do it. If we have enough time, we'll probably cover both, but the first way I'm going to discuss is calculating degree of saturation using this particular formula. Now, this one you're already familiar with. This is the specific humidity, which we're from calculating here. Now, this one is similar to this, but it's actually specific humidity at saturation. So when you look at degree of saturation, we're actually just comparing the specific humidity you have to the specific humidity under saturated conditions. So the W sub S is given by 0.622. This looks familiar, right? Now in this case we had PV, but in this case what we're going to have is pressure at saturation, PS, over PB minus P sub S. Now this pressure at saturation is simply the pressure you expect it to have for the dry bulb temperature, which is actually what we're given. The dry bulb temperature is 30 degrees. Now you check your steam table to obtain the value of PS at this particular temperature. When you check your steam table, you find that your PS is equals to 0.04242 bars. So to continue the calculation, the only value we're left with is probably P sub B, which we already know is P sub B is equals to 0.98642 bars. So units are very important, you shouldn't forget units. So our W of S will be equal to 0.622 multiplied by, you plug in the values, 0.04242 over 0.98642 minus 0.04242. So the value we obtain for WS is equals to 0.02795. Now this is in kg per kg. Of course, you'd have to convert this to grams per kg, right? This would give you 27.95 grams per kg. However, we're just going to use this same value and plug it in here to obtain our final answer. Or we could use the same value. Either way, we'll get the final answer as follows. So our W is 10.914. Of course, in the book you find they're using this one and this one. It's still one and the same thing. This is actually just in, this one is actually just in kilojoules, kgs per kgs, but this one is also in kgs per kg. So whether you use this one with this one or this one with this one, you get the same answer. But for the sake of understanding, I'll write both. So 10.914 over 27.95 is equals to 0.0109114 over 0.02795, which should give you, so I've written both. So this gives us a value of 0.39 actually. In percent, we'd have to multiply 0.39 by 100. So this is simply 0.39 by 100 which should give us 39%. And of course, in the actual book, they got 39.1. So you probably need to go through these calculations on your own just to be sure, but this is the value that I got. Thank you so much.